Okay, we are live.
Thanks, Ben. Welcome to everybody that's joining the meeting. We're a few minutes out from starting, but I just wanted to say hi and welcome. And I'll formally introduce myself in just a bit. I'm the new facilitator, but I've posted in the chat an invitation for RPAG members to please introduce themselves and your name, title, affiliation, and if you're inclined something you're appreciating about spring. So thanks for hanging in there, everybody.
So are we still testing audio?
We can.
You just heard me, so we're good.
Okay. I assume that's Nisi?
Yeah, that was Nisi.
Okay, great. Thank you, Nisi. Appreciate that. All right, I'm seeing a lot of people popping in. We're at 1 o'clock. I'm gonna give it about 15 more seconds and then we will officially get started with this RPAG meeting. Thanks for joining us today. All right, I am gonna go ahead and get us started for an on-time start. Welcome everybody to the main meeting of PSE's Resource Planning Advisory Group. We really appreciate your participation today. I'm a new face for all of you, so I'm gonna spend a couple minutes introducing myself so you know who your new facilitator is. I'm Hillary Wilkinson. I'm a senior communications specialist with Mall Foster and Alonji, and I'm the new facilitator for the RPAG. I'm really excited to be here. I have worked with Fortis BC's RPAG and it was set up to model after PSE's RPAG, so I'm quite familiar with the process and the topics and really happy to be joining all of you. I personally think this is some of the most important and difficult work being done today, and I'm really honored to be a small part of it. So with that, I'm looking forward to getting to know RPAG members a little bit better over the course of our time working together. For now, though, with a really packed agenda, what I'd love to have you do is introduce yourselves in the chat with your name, title, affiliation, and if you're inclined, share something fun about spring that you're appreciating. I know, at least in Bellingham, where I'm located, it's a gorgeous day, so I know we're all staring at a computer screen, but we can think about things that we're enjoying in springtime right now. So with that, I want to quickly walk through some introductory slides before we dive into our presentations for today. So next slide, please, Jack. Okay, there we go. This is just a review of how to engage in the meeting. So for RPAG members and PSE staff, you are welcome to use both the chat and the react buttons. For the chat button, we just ask that you make sure that the little blue toggle next to it says everyone. So you need to kind of click on it and make sure it says everyone and not just speakers, so that everyone who's participating in the meeting can see the questions and the comments that you're posting. So if you could just take a second to do that, that would be great. Also, the show captions button is, you can see real-time closed captioning with that button. Next slide, please. A few facilitator requests, these should look familiar. We ask that everybody engages constructively and courteously towards all participants. Respect the role of the facilitator to try to guide the group process and navigate the questions and answers. We ask that you try to avoid the use of acronyms and explain technical questions to make sure that everybody can understand them. We also ask that you use the feedback form or email this email address here for additional input to PSE. And my colleague, Ben, is going to post the feedback form in the chat here. There it is. Thank you, Ben. We ask that you try to stay focused on the topics of the webinar today to just kind of keep us on track and focused on these topics. A heads up that we will be taking public comments at the end of PSE's presentations. And another reminder, because this is really, really important, just for PSE staff and RPAG members to please make sure in the chat that you've clicked the everyone button so everyone can see comments and questions. Okay, next slide, please. Quick safety moment. May is electrical safety month. Never use extension cords continuously long-term. They can deteriorate the cord and create shock and fire hazards. Don't plug two extension cords together. They can overload your circuit. Don't allow extension cords to run through water or snow. And call before you dig. That 811 number will get your local utility out to mark the location of underground wires and gas lines, and they'll do that for free. Next slide. We have a lot of great speakers today, all from PSE. You probably know most, if not all of them, and I'll be formally introducing them as they speak, but this is just a list of all the speakers so you can get familiar with who they're going to be. Next slide, please. All right, here is today's agenda. You also have gotten it in an email and it's on PSE's website. So I'm not going to go through it in detail, but we have a lot to cover today, and an ask of all the speakers is that you try to stay to your time blocks to the degree possible. I'm going to pop on screen about a minute before your time block is over, just so you know, so if you see my face come up, you'll know that it's a little bit of a signal for you to move on. But we have a huge focus on the electric supply reference case today. That's the big chunk of time. You see that in the middle there, the 120 to 225. We will follow these timeframes to the degree possible, and we will also be flexible to make sure we're covering the topics adequately. Okay, next slide, please. Our main objectives for today is to make sure that the RPAG is very aware of what the reference case portfolio process has been and what the outcomes are, and make sure that you RPAG members are involved in key decisions regarding next steps. Where we're specifically going to dive into getting feedback from you is your reactions on the revised reference case assumptions. So we have several times where we're going to be asking specific questions of you. And a couple times I'll be doing kind of a round robin just to make sure that all RPAG members have a chance to weigh in on a couple critical questions. You can always pass if you don't have a comment, that's totally fine, but I just want to give you a heads up about that. How feedback will be used. As always, your feedback will be used for PSE to inform next steps. And in this case, the next step being finalizing the reference case and continuing with the scenarios and sensitivities. Next slide. All right, last slide before I hand it off to our first presenter. We ask for you to please share your questions and reflections and advice on today's topics. Let us know if anything's missing or unclear. Please flag areas where deeper discussion is needed, and then help us identify risks, tensions, or points of misalignment early. So with that, you can go to the next slide. I'm going to introduce Kara Durbin, who's the Director of Clean Energy Strategy for PSE. And Kara is going to be giving kind of a high-level overview of what the reference case is, what it includes, and what observations PSE is making about the reference case. I'm going to ask that people hold their questions until the question period at the end of Kara's presentation, so she can cover all the topics. And when we do get to that question period, if you could raise a virtual hand, I will call on you. So with that, Kara, I'm handing it off to you.
Thank you, Hillary, and good afternoon. Great to see everyone. For those of you who have been with us for a while, maybe for many of you since the 2025 resource planning process that then transitioned to the ISP, you've been patiently waiting for us to get to some initial results for this ISP, and so we've made it. That day is now here. We do have initial reference case results to share with you. And if we can go to the next slide, I'll just talk a little bit about our meeting purpose for today, and also note that we have time set aside in June so that we can dive deeper in areas that are of interest to RPAG members in understanding the reference case in its totality. So there's a lot of information in the appendix section of the slide deck. This was a very lengthy deck that we did send out. And that's really given the fact that there are so many different components that we're bringing together into this integrated system plan approach. And we really wanted to share the information from the different planning areas to really help you have a good sense of the reference case, while also knowing that there's a sort of a manageable amount of information that we can probably tackle in this first meeting. So we won't be going through the material in the appendix today, but we do encourage you to take a look at it. Let us know today or through the feedback report if there are particular areas that you have questions about and that you want us to spend more time in our June meeting together. Couple of other comments. I also want to remind everyone that this is our first ISP, and we are all learning and adjusting to what are new regulatory requirements and expectations. And so one area I wanted to mention on that note is one aspect of this ISP that is new is the requirement to translate total portfolio costs into potential rate impacts. And as many of you will recall, in a traditional IRP, we've always shown a total portfolio cost over the planning horizon. Now that looks a little bit different with House Bill 1589. Both the total portfolio cost is different because it's not just focused on supply, but also the delivery cost, the cost of programs. And we need to attempt to translate that total portfolio cost into estimated rate impacts. So Jen will walk through those estimated rate impacts for electric and gas for the full ISP reference case when we get a little bit later on in the meeting. I just really want to note that this is a new requirement, and we're including that information now really so we can begin a discussion with all of you on what this looks like and get any input you have on how we reflect this information as we move forward with other model runs and estimate costs and rate impacts for those. So it's important to note that they're not future rate projections for PSE, they're predicted cost impacts, and they're cost impacts for the reference case that are highly dependent on the assumptions that are being made in the modeling analysis. So Jen will talk about that more later, but I just wanted to note that up front. So our objective today is to walk through the material with you, as Hillary mentioned, get your feedback on the approach we took, given the modeling challenges we encountered on the electric side, and respond to any initial questions from you. We'll also, I believe, do a poll later on in the meeting and to gauge your interest in what you'd like to focus on in June and where we can go deeper. Okay, next slide, please. I think this is our timeline slide. Yes. Okay, so here's our updated timeline slide. It shows that we have a very busy several months ahead of us with all of you. Today, we're discussing the draft reference case, as well as revisiting the list of draft scenarios and sensitivities that we plan to run off of the reference case. We intend to review the results of those scenarios and sensitivities with you later this year, in sort of late summer, early fall. And then from there, we'll begin to iterate towards a preferred portfolio using the cost test, the decision framework, the public interest criteria that are in House Bill 1589, and your input to really shape what that preferred portfolio looks like. Our goal, and that you see here on the timeline, is to share a draft preferred portfolio with you and publish it near the end of the year, and solicit written feedback on that draft content before we make revisions and publish the final plan by our filing date, which is now less than a year away on April 1st. Okay, next slide, please. So we've shared this slide with you before. This is really just a reminder of what our reference case is. It's really a starting point for the analysis to follow, and our iterative process that will work with all of you to arrive at that preferred portfolio. So the reference case, generally speaking, is the least cost plan that meets all of our legal and policy requirements. And that includes things like CETA and CCA, but by no means are those two the only ones. It's what meets our legal requirements for the plan. And then we test different scenarios and sensitivities off of that reference case. Sensitivities test one variable. So for example, what if we change the assumptions on SMRs? How would that affect the cost of the plan? How would that affect the resource mix, the emissions, et cetera? And then scenarios are a little bit different because they change multiple variables at the same time, but they also give you a different view than say what the reference case is assuming for that potential future. Based on what we learned from the different scenarios and sensitivities, and through your input, we'll apply the cost test, the decision framework, and we'll iterate towards an actionable preferred portfolio. And I say actionable because we have an ISP implementation period, as stated in the law and the rules, of 2028 to 2030, with specific actions, and that we need to be able to implement at the level being proposed in the plan. And that's similar to our experience with the Clean Energy Implementation Plan, or CEIP, which has specific actions and targets that we're required to meet. And as you know, the CEIP is now a part of the ISP, so that will be reflected as well. Next slide, please. You've seen this slide before also. It's really just here to keep us all grounded in the fact that this first ISP and this ISP as a concept is bringing together several different planning components. It's bringing together generation, transmission, distribution planning, and customer programs such as DERs and conservation. So today we'll focus mostly on the electric supply and some of the transmission assumptions underlying the analysis, as well as gas supply. And then we'll get to delivery system planning if we have time today. If we don't, we'll make sure we cover that in June. But you'll find information about all the planning components in the appendix materials. And then we'll go from there in terms of focus for June. Next slide, please. I think this might be my last one before I transition it over. I think there's one. There we go. Okay, excellent. So we wanted to share at the outset just some initial observations as we've conducted this reference case work. Elizabeth will talk more in a bit about some of the electric supply portfolio work and the challenges we face there. These observations may prompt some questions from you all. I would ask that you hold your questions until a little bit later in the presentation, where Elizabeth and Jen and others can walk through the material, where I think that conversation can be more focused. And we'll also revisit these themes at the end of the meeting, and happy to take feedback as well. But stealing a little bit of the punchline from Elizabeth's section, which many of you have seen already from the materials, when we were using the assumptions that we had developed together with the RPAG around what to assume for the reference case, we found ourselves with an electric supply optimization model that wouldn't produce a solution, particularly when we went out and further into the planning horizon and looked at the milestone of 2045. So in order to have a reference case and a model that would solve, we had to make some different assumptions, which Elizabeth will talk about, and make some manual workarounds in the model so the model would solve, and we'd have a starting point for further analysis. It's really important that we emphasize this is a starting point. It's not the end point. It gives us a place to start so that we can then iterate and test different assumptions against the reference case. Also in Elizabeth's section, we'll go through what the peak capacity needs look like over the planning horizon, winter and summer peak, and as well as the clean energy needs for meeting our 2030 to 2033 CETA obligation of carbon neutrality, and then the growing CETA needs as we approach the 100% clean milestone in 2045. The needs for both peak capacity and CETA are significant, and we'll go through those numbers in a bit here. Also adding to the challenges is that transmission across the region is significantly constrained, and that poses risks when we think about the generation bills that will be needed to meet the demand that we're forecasting under the reference case. Another aspect that we'll touch on is the gas supply side, and the gas supply optimization model continues to select purchasing CCA allowances in addition to some level of RNG to offset emissions on the gas side. And then finally, Jem will talk later through the electric and gas rate slides. Again, these are estimates based on the assumptions in the model, but both show rates increasing significantly over the planning horizon, which does raise customer affordability concerns for us. So with that, Hillary, I will turn it back to you, and we'll see if there's any questions on the initial slides. Otherwise, I think we'll dig into the real work ahead.
Oh, thank you so much, Kara. So we have a couple minutes for any kind of big picture questions of Kara, recognizing that a lot of what you just shared, you'll be hearing in a lot more detail in just a little bit. So if you could raise a virtual hand or just come on screen and ask a question of Kara. I'm just going to give it a second here because I know sometimes it takes people a bit, but I'm not seeing any hands up unless I'm missing it. I don't think I am. All right, well, there's going to be lots of chance to ask questions in a little bit. So I think with that, thank you again, Kara. And I just want to underscore something Kara just mentioned, which is at the end of this session today, we're going to be launching a poll asking RPAG members for input on which of the topics you hear about today you'd like PSE to dive deeper into at the June RPAG meeting. So just kind of keep that front of mind as we're going through today's presentations, that we'll be asking that question. So with that, I'm going to go ahead and transition to our next speaker, Mark Lenson, who is the Manager of Strategic Planning, Evaluation, and Research. And Mark is going to be talking about reference case customer programs, especially around the demand side inputs. So with that, Mark, it's yours.
Thank you. Appreciate that. So we can go to the next slide. So I'm within the customer energy management group, and part of the team that's been responsible to provide the inputs related to customer programs. So I'm just going to walk through the kind of different flavors of those that we've provided as inputs, and then look at some numbers on the next slide. But I felt this would be important to be able to look at the next slide with basically the graph of the delivered megawatts. So within this draft reference case, actually go back. I'll just go through all five, and then if folks have questions, I guess, yeah, we'll wait to the end. I only have 3 slides, so I'll be pretty quick. So of the 5 flavors, we have conservation and energy efficiency. So Cadmus has been our conservation potential assessment provider for a number of years, and so we worked with them once again to supply the latest update to the assessment for the inputs into the 27 ISB. One wrinkle that we changed in this go around was not simply just looking at the Cadmus forecast, but we tried to blend the early 5 years or so to provide program input on numbers and targets. And so that helped shape kind of the front end of that curve from Cadmus, but we obviously still leverage their conservation potential assessment, which is a 20-25 year assessment of potential. Demand and response is pretty similar. That is housed within what we call the conservation potential assessment. Yes, that's not technically conservation, it's demand response, but that's just what we call that body of work, which is pretty massive. 2 other items, the next 2 items, DER solar and DER storage, are handled slightly differently. So we leverage the NREL DGen tool, modeling tool. We do that in-house to try to assess DER adoption rates. So there's things you can input into that model tool to help guide what could be forecasted or potential adoption rates of those particular technologies. And so again, that's different than what we do with Cadmus in the conservation potential assessment. And finally, net metered solar, that's kind of the behind the meter solar that is also considered in our conservation potential assessment scope. One clarification at the bottom there, Kara already talked about it, is the sensitivities versus scenarios. For the reference case, we will be applying sensitivity analysis to try to assess, is it possible to hit 2% conservation? Is it possible to hit 10% demand response? So we're using sensitivity analysis to assess that. And I would say just as important, we're also going to be using the sensitivity process to assess the traditional cost-effective bundle selection, because within energy efficiency, as we do our biennial conservation plans, we are on a 2-year cycle, develop plans and targets, and so we still need that information to help provide that benchmark for EIA compliance within Washington. So those are 2 different sensitivities we'll be using to assess those questions. Okay, next slide. This is just a quick summary of all the different customer inputs. Again, it's a starting point. One thing I didn't talk about in the previous slide is that we've included some of the existing DER solar and storage. So typically the conservation potential assessment and DGen are looking at forward looking, but we also need to include existing potential or existing systems in delivery of solar and storage. So those are included in there as well. It's not just new and forward looking, but it's also looking at existing. Okay. Yeah, good question. Nameplate versus delivered on peak is probably would have been helpful. Thank you for the feedback. Okay, next slide. Okay. Just some notes. So for energy efficiency, achieving 2% of the annual electric load will likely be virtually impossible with voluntary programs. As a reminder, we don't force customers to participate in our programs, but they are voluntary. So a 2% conservation target would about double what our 10-year average of delivered energy savings is or has been. So that is a pretty good signal or flag of showing a pretty significant gap between what we can do today and what a 2% target would require. As we look at the sensitivity for this to try to assess how is it possible, it's going to look at things that require technologies and solutions that aren't yet developed or in the marketplace today. Normally, we're not including that in our conservation potential assessments because we don't know when and how big those solutions will be, how cost effective they'd be. And so there's definitely typically limitations in looking at things that aren't yet market ready. And also one of the interesting challenges we've been seeing in the conservation potential assessment is how lighting continues to shrink. Back in the day, I've been here for over 20 years now. Lighting was bread and butter. Like we would be cranking through lots of lighting energy savings potential, getting people to fluorescent T5 and T8 back in the day for commercial customers, and now it's LED. Well, with some of the latest saturation rates for residential, as well as some of the state requirements on mercury lighting, which is kind of basically prohibiting fluorescent lighting in general across the state, really takes a hit on savings potential. So there's always codes and standards that are working against our programs. They provide benefits to the system in our reducing energy and peak, but they basically scoop those savings out of our conservation programs as achievable. For demand response, it's a little bit different mechanism when we talk about this 2%, 10% numbers or targets. From a 2% perspective for conservation, that's annually we're going to achieve these savings. So that's something we have to a fresh start January 1st of each calendar year. Compared to demand response, that's really that team building up a portfolio over time that could achieve the 10%. So if they're getting recruiting folks, let's say over time, that continues to build as a portfolio where again, the energy efficiency, we have a fresh start every year for that comparison. So they're really different beasts when we talk about comparing to the 2% and 10%. They're definitely apples and oranges. Couple just items through our conservation potential assessment learnings this go around. costs continue to increase regardless of a 2% requirement. There's still savings potential in communities that may require higher incentives to overcome affordability barriers. So those add cost to our program costs, labor, materials, and continue to increase in cost, but also the uncertainty with economic conditions can put some brakes or at least slow down the market's desire to spend money on things when they may prefer to hold off and wait to see how things shape up. And also at the end of the day, what we also wrestle with is, balancing how much we spend on DERs versus how much that impacts customer bills. So while things may provide a benefit, there's also a cost to that. So we need to be recognizing that as we move forward and try to shift and refine our portfolio of programs and offerings. I think that's all. So if anyone has questions.
Great. Well, thank you, Mark, so much for that presentation. That was a lot, and I suspect there are questions. There is one comment in the chat I just wanted to note from JP, a request to see the ELCC version of this chart. And ELCC, for those who are not in the know, is the effectiveness of effective load carrying capability, which is the effectiveness of a resource to meet system peaks as a percent of its nameplate. So I understand that PSE can provide that.
But not this minute.
So I'll let PSE speak to that. So thank you, JP, for that comment. I see a question from Lauren. Lauren, go ahead.
Yeah, thanks. So it wasn't totally clear to me, or at least from this presentation, Mark, how you guys might be doing the conservation potential assessment differently than you have in the past. I think there's this assumption that integrating these two systems, allows you to take into account, gas savings for electrification measures, et cetera. So could you talk a little bit about how and what, if any, changes Puget is making to the conservation potential assessment to address the dual fuel nature and the integrated intent of this plan? Thanks.
Yeah, no, that's a great question. Yeah, and I didn't really get into this detail. I think one thing that was absolutely different, this go around for the conservation potential assessment, or CPA, so I don't have to keep saying that, is trying to assess I think these are most acute in the scenarios that we're modeling, where we have kind of low, medium, and high, if you will, electrification. We did try to, which we haven't done in the past, but each one of those scenarios required a revised or a corresponding, if you will, CPA to be done. Because as you point out, as customers reduce gas use, they now actually are adding electric potential, because now as an electric customer with space heating or water heating, you could potentially do measures on that side of the wall instead of on the gas side. So that is something we did. We have not done it to this extent before. And so as we looked at the different scenarios, we really were trying to assess, okay, well, what's the net change on the energy efficiency and demand response potential as more and more customers via the scenario definitions were converting away from gas and to electric. What I don't think we did quantify, but I haven't really maybe reported in these terms of like, well, how much gas per customers was reduced. We do have an updated load forecast, but I don't think we've shared that kind of in detail how that changed. But that'll be forthcoming as we look into these different scenarios and how they impact both sides of the system forecasts and meeting those needs.
Thanks for that question, Lauren, and for your response, Mark. We have one more question from Mike, and I forgot to ask earlier for RPAG members, if you're able and willing, I'd love it if you came on camera when you ask questions or engaged. Selfishly for me, since I'm meeting everybody for the first time. So Mike, thank you. Go ahead.
Yeah, of course. Thank you, Hillary. Nice to meet you. And thanks for the presentation. Yeah, just to follow up on the request for the ELCC version of the chart. I think that'd be super helpful to see. Agree that that'd be a good addition. curious where Puget would be pulling the ELCC information from, whether that's something that you guys have kind of calculated internally or looking at any kind of external sources for.
I might ask for someone to help. That's not my expertise. I will say that I think for the like conservation codes, we use that number may not change because I think that what we are sharing in the numbers does include it just we don't say, oh, this is some level. I think some of the other more dynamic DERs would have a necessary number. I feel like I think this chart may have already accounted for that, but we'll have to get back to you. If anyone else wants to jump on and kind of refine that answer on how we do that. My answer is pretty high level of what it says. There's a load shape that we provide energy savings through, and that's basically how we would assess an ELCC for a kind of a customer facing program.
I can jump in.
Go ahead, Elizabeth. Great.
So I do have a picture later on in the presentation that will go through the peak requirements, ELCCs of the resources. So when we run this, we actually run this through our resource adequacy analysis to get the ELCC values specifically on the DER and demand response resources. We run the resource adequacy net of conservation. So this is looking at the full hourly load shapes of the conservation, how it can reduce our loads. And then looking at the various adjustments that are happening to loads within those hours as well. So that's really how we're running through the LCCs for the resources.
Okay, great. Yeah, that's helpful and might have some follow-up questions in that part of the presentation. Elizabeth, appreciate it.
Yeah, thanks for hopping on, Elizabeth, and thanks for that question, Mike. I think that in the interest of time, and I don't see any more hands raised or anything in the chat, I think we're going to go ahead and pivot to our next topic, which is our deep dive on the electric supply reference case. And we have a couple presenters for this portion of the agenda. We have Elizabeth Hosner, who you just heard online, and Elizabeth is the manager of the resource planning and analysis section at PSE, and she'll be joined by Sean Foster, who is the director of electric transmission. And this is the segment of the agenda where we have a couple sections where we're going to engage our RPAG members with some specific questions. So just kind of be prepared for that. And with that, Elizabeth, I am going to hand it over to you.
All right, thank you. So I will be reviewing through the electric supply reference case. As Karen noted, we've made adjustments. We set up the models based off of feedback we received. We're making some further adjustments in here. We're going to be going through kind of where the adjustments happened and the kind of results of what we're seeing with this reference case. So I think next slide, please. And there we go. So just kind of setting up the process we work through on the electric supply. We set up what we start with is the resource requirements. And I'll go through all the different stages of the resource requirements that we work with. We then set up all of our assumptions that we need as our starting point for running the reference. And then we go into portfolio modeling. So we're kind of we're within that purple box right now, working through the portfolio modeling. And what we do is a pretty inherent iterative process, even within our modeling process and with other teams. And so what we are going to do is we have our starting point assumptions, and that's what this reference case is. And then we go back to our assumptions, make changes to the assumptions, and then run that back through the model. So we get multiple different portfolios depending on the assumptions you're making, and we can see how those assumptions change the results of the portfolio. So we'll get different builds, emissions, costs of these different portfolios. And this is where all this scenario and sensitivity analysis will be. This will be multiple different iterations. We'll be running through these different portfolios, and all of this will be working to helping inform where to go with that resource plan. So later in the year, we'll be starting to talk about kind of that orange box, developing the resource plan once we start getting more results and more information on where to go with that. And then that'll further lead into kind of that final step is where we put together the action plan for the resource plan. But that will be kind of one of the last steps we work through is that piece. And so I think next slide. So going through kind of setting up our resource requirements, we work with 3 main levels of requirements, and all of these are working within our optimization model to meet each piece. And so kind of the first piece that we work through being the peak capacity. And so this is where we're working with our resource adequacy analysis. We're setting up a planning reserve margin and the ELCCs, or the peak contribution of these resources, to meet the peaks and the planning reserve margin, and how well these resources will operate under high demand hours, with a lot of what happens under low hydro or low wind, solar, higher loads, what's happening under all these different conditions, and how these resources can operate during these kind of conditions and events. That's really that effective peak capacity. The next piece is going through the CETA requirements. And so this is setting up for hitting that first compliance period, the 80% requirement over that 4-year compliance period. So we're setting this up as a kind of minimum energy requirement in the model. So the model must hit a minimum energy at the 80% to make sure we hit the compliance periods. And then that grows to 100% by 2045. And then the third piece is the energy demand. And so this is really where we're looking at the hourly load shapes. So we have the hourly load shapes, which are being put into the model all the way out through the end of our time horizon, 2050. And this is really important because as uses change over time, we're accounting for this in the change of those shapes. And so as we see uses change and how people are using the energy change, we're making the adjustments into those hourly shapes. And this will help inform. This is where a lot of the pieces come in for programs such as load shifting type programs versus peak shaving type programs. This is, energy storage and how you can shift energy into the higher demand hours and when you need that energy shifted. And this is important for bringing the different value streams into the models and in the flexibility of hitting your balancing requirements, and in making adjustments as loads change or wind or solar generation changes. You can make changes within those hours too. And so each one of these pieces has a value. So maybe a resource doesn't necessarily have a high peak capacity value, but it has a lot of energy value. And this is how we're lining everything up. So a resource that can meet all three of these, we'll see all the values of those resources versus different pieces of these different resource requirements that we're trying to meet. We're trying to put together the whole portfolio to make sure that demand is met in every hour in the lowest cost way by meeting these requirements. And so that's really where our starting point is. We set up assumptions to get to that starting point. And so this is just kind of the results of that starting point of assumptions that we're kind of working through. So I think next slide. This is looking at that peak capacity requirement. So there's a couple things to unpack in this picture. The first one, the line you see, that is the peak load net of conservation. So we've already taken conservation effects off the peak. And so that is the line already adjusted for conservation. And then we add the planning reserve margin on top of that. So that's that peak net conservation plus the planning reserve margin. And so that's what that kind of blue line at the top is. And then the other resources, as you saw, these are all of our supply side resources and demand side resources that we've accounted for in these peak contributions. And I think there was a question, we can isolate out the kind of demand side pieces in here as well so that we can use the different, so we can see how those are bringing into the peak requirements. And so just kind of looking through, this is on the left-hand side of your screen, you'll see summer peak. And the right-hand side, you'll see winter peak. And so the two pieces is your immediate near-term needs. And so in the summer, the resources are enough for meeting the summer peak plus planning reserve margin for those near-term needs. It's really the story is in the winter requirements. So we're seeing a much higher deficit in the winter, and this is going to be driving a lot of those resource builds to meeting that winter peak as well, since this is the highest demand requirement. And so a couple of things to note, that white box on top, that's called portfolio effects. The E3 went through this in September. What that is the interactive effects of resources together. And it's how those resources are interacting together within the portfolio. It's not necessarily attributed to any specific resources because it's how they all work together to meet the peak requirements. And so it was all that information was gathered and was kind of put into this bucket called portfolio effects, since we didn't couldn't really attribute to any specific one resource. So it's just everything working together. That's what that kind of portfolio effects bucket at the top is looking at. And so the second piece of this is what's happening with the gas plants. And so in previous IRPs and the progress report, we assumed those gas plants would just convert to some sort of alternative fuel, RNG, or we have used hydrogen for blending before. Those are some of the different assumptions we've made before. And so they were included past 2045. We've received quite a bit of feedback in the 21 and the 23 reports. And so we worked back and forth what to do with this. There was a lot of assumptions on if they convert. We just assumed they would do direct convert, put the fuel in, and we were missing a lot of costs in there of what it would be required to upgrade facilities to be able to handle different fuels. And so in this one, we've changed the approach and moved it into more of a full replacement of the plants. And so what we're going to be seeing is a full replacement of those resources by 2045. And so it's building into the replacement to making sure we've got the full replacement. And then that when you look at the 2045, you see the large drop. That's really what's happening is the loss of contracts plus the loss of those existing resources with a full replacement to make sure we meet everything. And this is where we are having to solve issues because that is a very large need to try and solve with commercially available resources today, given the CETA requirements for 100% renewable and non-emitting by 2045. So this is really an important piece of the story of what's happening and going into the future. I think I saw a quick question that I can answer. So the planning margin that we are using, this was discussed in September. It's a 20% winter and 12% summer PRM through the latest resource adequacy study. So all that information was in the September 30th RPAG meeting. I don't know if we want to stop for questions. This might be a good time. It's a lot of information.
Yeah, no, that's great, Elizabeth. I was just about to hop on. Yeah, let's go ahead and do that. Katie, go ahead.
Yeah, thanks. Hey, Elizabeth. I'm just wondering if you can remind us, I know that we talked about load growth a couple RPAG meetings ago, but to what extent do large loads contribute to load growth in PSE's profile here in this, especially, this peak capacity screenshot that we're seeing?
So this is our reference load. It includes kind of a middle of the line EV forecast in there, but there is not much large loads forecast in here. A lot of that growth is from the EV forecast. We are running sensitivities that look at increasing levels of EV adoption and large load adoption along with the building electrification in there. So this is kind of our starting point. We are just looking at kind of natural business as usual, the starting point right now as we're seeing things, and then we'll be working with different load growths into the scenarios at different levels of adoption as well.
Thanks.
Okay, I think next slide. So just to note, this slide is looking at nameplate capacity is different from the last one that we were looking at, which was the peak contribution. This is the nameplate contribution. All of these resources are included in the previous picture with their ELCC adjustments. But this is just kind of going through all the new resources that we're including into this portfolio in our current look for resource requirements. So we are accounting for all the resources that we've acquired, everything existing and online today, plus all the new resources that are expected to be online within the next few years. So this includes the retirements that we've seen over the last several years, expiration of contracts, plus all the new resources that we'll be seeing going into the future. It's quite a wide range, a lot of resources coming in as well that's expected in this portfolio. So this is kind of our starting point that we're working with for the resource requirements. I think we want to stop for a question.
Yeah, let's go ahead and take one question and then we'll hold questions until we get to the a few slides in. Go ahead, Gwen.
Hi, Elizabeth. And for Hillary's sake, Quinn Weber with Washington UTC. I'm curious, what is the differentiation between contracts and the rest of the resources? Is contracts just refer to more market purchases or something else?
They are more intermediate term contracts versus a lot of the other resources. Those are our long, like even if we do have like a wind contract, that is a longer term, like 20+ year type versus these contracts are intermediate term, kind of a 5 year or less. I saw Carrie come in case she wants to clarify, but yeah.
Yeah, Kara, do you want to add to
No,
that?
Elizabeth covered.
Okay. You nailed it, Elizabeth. Thank you.
All right, we'll move to the next slide. So this is looking at our CETA requirement and building into meeting that 2045 100% requirement. And like as I noted, includes all of our existing plus planned resources to come in the next few years. And looking at that first compliance period, the 2030 through 33 compliance period, we'll be setting it to make sure we hit the 80% average over the 4-year period, and then building into the 100% requirement by 2045. So to hit that first compliance period, it's looking at about just under 3 terawatt hours of resources needed. This is the renewable non-emitting resources needed to hit that requirement. And just noting that we also have built-in information for what's the alternative compliance to make sure it hits the 100% carbon neutral as well. So all of that will be built into kind of the portfolio costs that you'll see at the end as well.
This is Jamie from Walmart. I can't raise my hand, but can I ask a question?
Go ahead.
Sorry. So one of the things that we've been noticing in other states is that given the very large load requirements that, the customers coming on the system, some of the utilities that we work with are having to back off of their clean requirements or commitments that they've made a long time ago. And it's got me thinking about, what does the utility do, or how does the utility treat those assets that, customers have paid for, or they will be paying for as you move towards these commitments, which are valuable and important. But then once the utility backs off of that, are those stranded costs? Are like, what does that look like, and how does the utility contemplate even thinking about that, with the acknowledgement that if you have a very large load coming on the system over the next decades, you may not be able to aggressively meet those goals, and then you're sort of paying to ramp up really quickly to clean requirements, but then you still can't get there.
Elizabeth, I'm happy to take that question, and you can back me up with a little more context if you'd like. I mean, Jamie, we're situated a little bit differently than some other utilities in terms of we don't currently have any large customers along the lines of what you're indicating. We do, and this is more than a commitment for us, right? This is the requirement of the Clean Energy Transformation Act that we achieve that carbon neutrality over the 2030 to 2033 compliance period. So we're in the middle of an active all-source RFP seeking to both fill the capacity need that Elizabeth indicated and our clean energy needs to meet that requirement. So I think, we are obligated to keep moving forward and looking to fill that gap. And what Elizabeth is showing is that we've made progress since CETA was enacted, in moving from approximately 34% clean to 58% almost clean energy by 2025, and we still have a ways to go, and the model's projecting what that gap is. So I think we're in a little bit of a different place than some other utilities, and we're really just showing you where we're at and where we're projected to need to go, both in the near term and longer term. I hope that helps answer your question a little bit.
I appreciate that. I'm only raising it as sort of a thought experiment, because when the other utilities that we are engaged with were making those commitments, and it's true that some of that moves through legislation, but some of it starts with utilities and coalitions and then moves through legislation. But they weren't necessarily experiencing those large loads when those commitments and obligations were put in place. And what I'm saying is, when the large loads come on after the fact, that has been what's causing it. And so I'm just thinking about sort of future proofing, at least in terms of contemplation. That's all.
Thanks, Jamie. No, appreciate your comments. And there is a large load docket open at the Utilities and Transportation Commission that is wrestling with some of these questions. So that might be a place that we could look to the conversation there as well. But thank you for the comment.
All right. I think there's more questions. We can keep going if you want to go to the next slide. Oh, do we have time for one more?
Yeah, let's have this be the last question for now. There will be time later, but I want to make sure Elizabeth has time to get through her presentation. So go ahead, Lauren.
Yeah, just going back to the previous slide, I was looking for a little bit more specificity on what might be baked into the baseline generation assumptions that have sort of fallen into this inter-planning period where there was no resource planning happening. So like, for example, is the TransAlta tolling agreement included as an existing resource here, and what else might be baked in?
So this includes, actually, if you want to go back one more slide, this includes, as you noted, all of the resources that are currently online and planned for the next several years. So this is all baked into kind of our baseline assumptions. And yes, this does include the new tolling. This includes the new resources, wind, solar, batteries, everything that is expected to come online before 2030 as well, currently in the process. And all of this is in our baseline, and we're accounting for our needs net of these resources.
Thanks, Elizabeth. Sorry, just to clarify. So the 700 megawatts of peakers and CCTs include both the TransAlta tolling agreement as well as a number of other gas plants, which has Puget ordered that equipment yet, or were they approved through an RFP process? Sort of what is in that 700 and the contracts? I'm just like we understand, wind, storage, all that stuff came through the RFP, but what is contracts, and then what specifically is the peaker and CCT bucket?
So that peaker CCT is directly that one tolling agreement. That's the gas conversion agreement. That's the full nameplate of the resource. In the contracts, those are our short or intermediate term resources. Those are those other contracts, as you noted, that would be under the intermediate term resources. This is everything that we know and is planned as of when we kind of time stamped this late last year for resources.
Okay, thank you.
Thanks, Lauren. I think you can continue, Elizabeth, and then we'll get to slide 32 and we'll have a round robin of RPAG members.
All right, thank you. So this is just kind of going through our portfolio modeling process. So where we start is what we call this deterministic portfolio analysis. This is kind of where we look at normal conditions. So this is like average hydro, normal weather for our load forecast, and a P50 wind and solar. And this is what we go through for planning. So when we look at the resource builds, this is meeting to what we're calling normal or average conditions. And so that's what's being built into the deterministic model. We have kind of a base electric forecast and a base gas forecast that go in that's the same as what goes into the gas modeling, along with the kind of high ceiling CCA costs as well. And so all of this goes into that deterministic modeling, and we'll be using all these assumptions to kind of work through the different sensitivities, making adjustments depending on which sensitivity we're looking at. The stochastic analysis will follow, and that's more testing kind of robustness of these portfolios. And this is where we're going to putting a lot more of those risk parameters in. What if um, the looking at the wide range of what could happen to power prices, gas prices, hydro generation, wind, solar, and we're going to be looking through all these different draws and how these portfolios will be performing under these different conditions. And so that's really where we're going to get some of the volatility and those risk parameters going with the portfolio versus what we're doing right now is just kind of our deterministic analysis. I think next slide. And so this is really going into what happened between the last time, the 23 progress report, versus what's going on now and why we're having trouble getting the model to solve. And so in the 23 progress report, we included emerging technology, we included the gas plant conversion and the availability of alternative fuels for existing and new thermal resources. And we included a couple different CETA compliant fuels as options into that progress report. And that's where we got the result of the 23 progress report, was really based off of these fuel conversions and availability of these alternative fuels. Really, we got quite a bit of feedback. We discussed this last year. It was about a year ago. We went through the generic resource options. We went back and forth. What do we do with emerging technologies? How do we handle this? We got pretty mixed feedback on what do we do with emerging technology. The question really came through of what's the risk around the emerging technology? If it's not available, what will that look like versus if it's available? Would that change some of those? Would it change what we do in the next 10 years if we have the emerging technology available? And so what's happening in those different conditions is we got feedback. We decided based off of the rules and requirements for looking at commercially available technology. We pulled the emerging technology out of the reference case. So we were just working with wind, solar, and the lithium ion battery, the short-term batteries, as the currently commercially available technologies. And then this was also looking at full replacements of those thermal resources by 2045. A lot of questions have come up also about alternative fuels and availability of the alternative fuels by 2045. Just to note, we are assuming biodiesel for this ISP is our alternative CETA compliant fuel. It is commercially available today. You can do some biodiesel units today or biofuel, different peaking units today. The question came about as in the 23 progress report, a significant number of peakers were needed. So it was relied pretty heavily on as a resource alternative for meeting peak capacity requirements that was a CETA qualifying resource. And so given the amount of resources that needed to be added to meet resource adequacy, the question came up of, is that amount of fuel available? And we're just not sure what would be available in 2045. And given the questions about the fuel availability, what would be the limits of what we could get? We're just not sure. And so given those risks and uncertainty, we moved the alternative fuel also to emerging technology. And so that's really where the limits have come in. Just given what we know today, availability of resources today, solving for that 2045 solution became quite difficult. And this was, as I noted from the peak picture, it's a 5,000 megawatt peak deficit. And so we're working with the ELCCs and availability resources for meeting that peak deficit. And just given the full saturation happening on the wind, solar, and batteries, they are just not capable of hitting that amount of peak credits. And so you have to use so much of those resources to make sure you're hitting your reliability standards in the portfolio that it became quite unrealistic of the amount of resources you needed to do that. And so we were pushing up against a lot of build limits because we do put build limits in, they are quite large, but we pushed up against a lot of those build limits is really where we were hitting for those constraints. So if you want to go to the next slide, please. How do we solve the problem? If we can't get these resources to meet 2045, where did the solutions come in? And so the first option being to release the build limits that we were seeing on the resources to get it to solve. This inherently did cause a lot of problems because so much resources were needed to build into the replacement that the model just was having difficulty solving into this problem. And so we had to really manually push the model along to get into this solution for option one with these very large amounts of resources. And that brought us to kind of the option of what if we put emerging technology back in along with the alternative fuels? And once we did that, we were able to get the model to solve. We didn't have to kind of push it along, and it was able to move into a solution as well. So I think next slide, please. So this kind of goes through the solutions that we were getting for both of those options. So reference A, this is where we're working with commercially available technology only. That's the wind, solar, and the 4-hour batteries available in 2045. And so what's happening there is in the first part of reference A is we still see the peakers coming in. And this is really given that is the most readily available and best solution for meeting kind of those near-term peak capacity requirements. And in this model, we actually set it so they were fully depreciated by 2044, and they came offline and retired and then replaced by resources afterwards. And even at the full depreciation, a shortened 10 plus year depreciation on them, we were still seeing them coming into the models, given that is that short-term requirements for resource adequacy from hitting those standards. And then you build into quite a significant amount of 4-hour batteries. And so what's happening is by the time you reach this point, batteries have fully saturated through what we called the last tranche. This was tranche 3 of saturation of the batteries. That's also where our build limits were coming from, is like the full saturation out through tranche 3. That was what we set as our build limits. It was a pretty high number, but we had to far exceed out past tranche 3, which we didn't go past tranche 3. So we assumed all of these batteries got a 10% ELCC, which is where it's fully saturated at. And that's why you're seeing such a significant amount of batteries coming in. This is a large amount of batteries, just about 55,000 megawatt nameplate of batteries just to solve into this problem, which is quite a bit. It's looking at, land use for that is well over 5,000 megawatts of, or sorry, 5,000 acres of land needed for these batteries. They require a significant amount of land too. They're large containers. They require land to also put them in as well, is quite significant. And given that we also had to really manually move this model along, it was very hard to solve. But when we put the emerging tech back in, this was the alternative fuels, so those biofuel peakers we put back in, and the ability for a natural gas peaker to then convert to biofuel by 2045. So those peakers, those flex fuel peakers, some of them are gas that convert, some of them are just biofuel peakers coming in. It's, as you can see, it is a significant amount of peakers coming in as well. And then we have storage also coming in. And so really what's happening is, yes, they don't have that great of peak contribution given the low ELCCs and saturation, but they are still coming in. As I noted, there's a lot of other things we're moving through. So we have to meet CETA requirements. There's wind and solar coming in, and it's those hourly loads. And so the storage can really help moving the generation from those intermittent resources into the hours when it's needed. They also can be used for flexibility, ancillary services. So they do have quite a bit of other value besides peaks. We're still seeing the storage coming in to those as well, on top of some of the peakers for meeting those resource adequacy requirements. And then we have the wind and solar coming in for meeting the CETA renewable requirements. And then in the later years is really where we're seeing some of those more other emerging technologies. And so we did see nuclear and geothermal coming in. The other options not selected were offshore wind. We also put in mid and long duration storage. The storage really stuck to kind of more the short duration, as opposed to the longer durations as well, given that the long duration also saturates after a point. There's a lot of information. And I don't know if we want to stop. I think I saw the chat going and there's a hand up.
Yeah, Elizabeth, I'm gonna have you continue. John, if you could just hold your question just for a couple more slides, and then we're gonna pause for questions. Thank you.
Okay. So we're going to go to the next slide then. So this is looking at the total portfolio costs. And so again, there's a few different stories going on here. The first story is from the 23 progress report. We are seeing a significant increase in costs, just total costs of the portfolio. And really what's happening there is this is a lot having to do with the resource costs. We are seeing significant increases in costs to resources themselves. We did a kind of a reevaluation in the fall of what's happening in the current markets to making sure we're capturing the current costs of resources. And so that's going into here. We're also accounting for the One Big Beautiful Bill, which we see the sunset of the ITC PTCs, which is further increasing those resource costs because that was the wind, solar, battery, nuclear, also ITC PTCs that ended up getting sunset as well. And then we are also bringing in transmissions. We have Sean coming in later. What's happening on the transmission front? So really what's happening is we're bringing in a lot more information, and this is that iterative process with transmission that we've been working through to making sure we're hitting the total capacity of the transmission availability, building into what's available of transmission, the costs to achieve this level of transmission, all the upgrades that will have to happen is pretty significant costs we're going through with upgrades, new transmission that may be coming in, and those limits on the transmission, making sure we're hitting capacity and the flow and we're not exceeding what's happening. All of that is coming into what's happening with resource costs. Or sorry, the total cost of the portfolio. So this is really what's bringing us to the total portfolio costs increasing over time as well, and especially in the last 3 years, what we've seen of the resources. And so then we're just noting kind of what's happening between A and B. A being having that unrealistic amount of resources coming in is a significant cost. You're seeing huge amount of cost to bring those resources in, versus B, where we're bringing in those emerging tech, allowing for the alternative fuels, also to meeting those resource adequacy requirements into the future. And I think we're gonna keep going, and I'll take questions, or I think is this my last slide?
Yeah, like pause, if you could actually go back a slide, Jack, and just kind of pause on this slide. Thank you so much, Elizabeth. That was great information. I know this generated a lot of thinking and good thoughts. So really quickly, we have a break coming up at 2:25. We're going to honor that break because I know it's hard to stare at a computer screen for a long time. We are going to go ahead and continue this part of the agenda post break to make sure we give it adequate time because it's a lot to digest and we have some questions of all of you. So just kind of giving you a heads up on that. Right now, we're just gonna make sure we can take a few clarifying questions. I just wanted to note that Katie had posted in the chat, appreciating the clarity on biodiesel falling into emerging tech as a category, and asked for more details on what else is considered emerging tech. Elizabeth, I believe you just went into that a lot, so I think that question's been answered, Katie, but if not, ask it again in the chat and we'll circle back to it. But I wanted to give John a chance to ask a question. John, thank you for your patience, and go ahead and come online.
Yeah, thanks. I was wondering, Elizabeth, you talked about some of the short duration storage and long duration storage saturating. Are you referring to kind of its capacity contribution value? And if so, maybe, well, I guess what I would say is, could you elaborate on that, the saturation? That'd be useful. Thank you.
Yeah, so this was part of our resource adequacy analysis and how these energy storage resources can contribute to peaks. And so as we saw the previous slide, we already have some batteries coming in. And so we're looking at the next new set of batteries on top of that. So with the batteries coming in, that gets the value. And so beyond that 700 megawatts of batteries, the next set of batteries, we're now looking at the saturation. So we've already got batteries in. Now we're looking at new batteries. And so those new batteries are coming in at a saturation point. And so it's coming in, I think, from the September, this was in the September meeting, those saturation curves. So those next tranches coming in are about 25% and then dropping to 10% ELCC contributions. And so what's happening is as you're meeting your immediate peak, so you've got your kind of the shorter piece of the peak, which the batteries can help. And what's happening is that you're meeting your first 4 hours. And then you're cutting off kind of that top of the peak. And then you're moving down into your next step, which is further and further duration of those events. And so those batteries can meet that kind of super immediate peak, but they can't sustain the duration. And that's where we're seeing the saturation of the batteries is as long as you start having these events with longer and longer durations, they can't sustain. And given the availability of resources during these events, you are in a supply shortage. You cannot recharge your batteries during an event. So once they're used for that event. And so as you get more in, they are saturating over time. And the more you get, the less it will contribute to those peak events.
Yeah, thanks, Elizabeth. And I think that that makes sense kind of in the absence of additional energy resources that would be providing, more power. Can you remind me on those saturation curves? Sorry, just to clarify again, were they incorporating kind of what would happen as the portfolio changes, say as like more renewables came in or more other energy resources, regardless, came in and would be adding more energy to the system that the batteries could be shifting around?
So what the saturation we did is we did a 2031 and 2037 future look. And so we worked with E3 and E3, we set it to using the E3's regional analysis. And so that was our market conditions and availability of resources. They made sure the region was balanced. So this is working with a balanced region with enough resources in there in the markets to making sure there's access into the market for these batteries. And then what they did is they then balanced PSE's portfolio. So they balanced out PSE's portfolio with what's called this perfect capacity resource. And then they backed out perfect capacity with these resources to get kind of the incremental. And so they just did more and more of these resources to get a saturation point of each of the different types of resources and how that versus the rest of the resources can meet into PSE's peak contributions.
Okay, thanks, Elizabeth. Appreciate it.
Thank you, John, for that question. We also have a question from Sophie. Go ahead, Sophie.
All right, thank you. So just as a clarifying question at this point, Elizabeth, could you say a bit more about why this battery result was not realistic? I can see that the price is very high, so putting that aside for the moment, is it just the area that the batteries would need to take that seems unrealistic? I guess I'm also curious with this, and this relates to John's question. Is it partly unrealistic because we don't have the energy to charge this number of batteries? Or has the modeling fully encompassed, the need to charge those batteries, the short-term batteries, to make them useful? Wondering if that's part of what's making it unrealistic or if there's some other elements.
So what this is, the unrealistic number one being the land use needed. Number two being the system being able to handle all of this generation at once on the system. This is incredibly magnitudes of generation being added to the system. So this would include a significant amount of generation or system transmission upgrades that we haven't even accounted for those costs that would have to happen to handle all this generation and interconnect all this generation onto the system in terms of, and also supply. Can we even get this amount of batteries? This is almost double the current installed capacity in the US. This is a significant amount that we're talking about. Could we even get this? I mean, I'm sure we're just a small utility. What can we even get to in terms of the availability of these resources as well? Because there's pretty high competition to get to resources, which is also why we're seeing the increase in resource costs.
Thanks for that question, Sophie, and your response, Elizabeth. Question from Quinn. Go ahead, Quinn.
Yeah, I am a little curious about in the case of reference B, where like RNG kind of fits in with this, and if there is like potentially some interactive effects between needing to decarbonize on the gas system for like home heating end use and more residential and commercial end uses, and like what that would look like with the availability of RNG in that scenario.
Oh, RNG's, so RNG has the benefit of a fuel that could be used today in the resources. There's no upgrades or any changes that would have to be on the gas plants in order to use RNG versus natural gas. The question again would be availability of RNG. We are assuming RNG into the gas system, so we'll be working on that. And since we're assuming it on gas side, we weren't sure what would be available for the electric, so we didn't use it. But I mean, we've talked back and forth about RNG and availability, so that's also one of the questions we've been working with as well.
Thanks for that question, Quinn, and for your response, Elizabeth. We have one more question from Katie, and then actually, Sophie, I'm going to ask you to hold your question if you don't mind, because I want to pivot to the question we have for you. I don't want to miss an opportunity to get some feedback from all of you, and that may be an opportunity to weave in your question or comment. So Katie, go ahead.
Thanks. So earlier in the chat, I mentioned emerging technologies, and I just wanted to make the point, it doesn't necessarily need to be a question, but I do feel like reference case A could have been either built out a little bit differently, or there could have been a sort of middle of the road approach where some of those technologies were considered available to an extent, such as biodiesel in the early years, not to, sort of paint it as impossible until, you move it into reference case B, and other durations of battery storage. I know that there was a pilot announced in early, I think, 2024 with Form Energy for a long duration storage project. And I do think that there's opportunity to include things like that in a reference case, whether it be A or sort of a middle of the road reference case, to explore the cost impact and the way that that could contribute to resource adequacy needs. I'll just throw that out there as sort of my pitch, but I have a question about sort of getting to the issue on why the model wouldn't solve. Elizabeth, I talked to you a little bit about this before, but I want to hammer the point of what exactly prevented reference case A from solving versus reference case B.
So we were just dealing with a lot of trouble with the model, just given the magnitude of energy storage needed to solve the problem. The model kept stalling out and wasn't getting to the answer. And so we just kept trying to manually having to feed in information to keep getting it going. We had to start early for the build out to making sure we got to that answer by 2045. So we had to like move the builds earlier and earlier to start incrementing it in, and that helped trying to get to the answer. And so we had to really kind of push it along. What was happening is it likes to keep the gas plants all the way to the end because those are the lowest cost resources, but then it can't solve that large problem all in 1 year. And it's just kind of kept iterating through. And so that's really where we were just dealing with kind of this modeling issue of like trying to solve in 1 year and just really trying to get it to push along and bring in solutions earlier to ramp into that final solution.
Okay, so it's not necessarily the vast capacity need, and it's not only transmission constraints. You're saying that it's something about the model that wasn't allowing it to continue along the way.
Yeah. Yeah, it kind of got itself into a stuck. And so we just had to kind of push it along to making sure it can solve into a solution.
Okay, I guess maybe we could think later about ways to poke at it and try to figure out what exactly was slowing it down. And, especially when reference case B had no issue, it'd be great to understand sort of what that difference is. Thank you.
Yeah, and I'll also say kind of in between cases, I'll be talking later on sensitivities, and this is where we're going to still start trying to build in these kind of what if these in between cases. And so we'll kind of get to that in a few slides as well, kind of building in some different options.
All right, thank you, Elizabeth, and thank you everybody for those great questions. I know that there are more and there's some things flowing in the chat, and we will circle back to them. We have about 4 minutes until our break, so I kind of want to set the stage for what we're asking of RPAG members right now. You just heard a lot from Elizabeth, and landing on reference B as being the model that solved for PSE, and there were some great questions and comments about, more details about why A didn't solve, so we recognize that. But our question for you is just now that you've heard the challenges that PSE was up against with solving this reference case and that B is the one that it looks like they're going to move forward with, we'd like to know your observations, just sort of like a gut check on it, pretty high level. And we'd like to give each RPAG member a chance to share those thoughts. And we're not going to get through all of you before the break, but maybe we can get through one or two. And I'm calling on folks not in a bit of a random order, so there's no rhyme or reason to this. And if you have nothing to share, that's fine, just say pass. But I would like to start with Dennis. Dennis, are you on?
I am on.
Great. Do you have anything to share about your observations on this recommended reference case?
One of the things I'm looking at right now is, and maybe I'm trying to write it out, but with regard to building transmission capacity, is PSE considering date-driven gates to account for build-out lead times to achieve transmission capacity for anticipated emerging technologies within the region?
Okay, thank you, Dennis. We're gonna take notes on this and not answer the questions here unless Elizabeth, it's like a quick response. But I appreciate that comment, Dennis. Thank you. Next, let's go with Eliza. I know you just joined, so you may not have seen enough of the presentation to have thoughts, but I'd love to hear your thoughts if you have any.
Yeah, I did just join. What I don't have the benefit of hearing was all the discussion. But generally, when I had the initial walkthrough with Elizabeth and team, I could understand why they were recommending to use B as the reference case. I mean, I think overall is just trying to think about, now what we're going to compare it to, and will there be issues with other sensitivities? But overall, I'm in support. I think of going with this reference case.
Great, thank you for that, Eliza. Appreciate that. We have 1 more minute, so I think I'm gonna call on Jamie next. Jamie, are you still here? Okay, we'll come back to Jamie. Callie, are you on?
Hi, yes, I'm on.
Great. All right. Do you have any thoughts on this reference case B?
No, I appreciate PSE walked me through it last week. And I think what they're saying makes sense. So yeah, interested to hear what everyone else thinks.
Okay. Thank you, Callie. All right, we have time for more. How about we go with Lauren next? Okay, I think Lauren may have stepped away, so we'll come back to Lauren. And let's go with JP. Actually, I think JP stepped away too. He texted that. Let's go with Katie.
Thanks, Hillary. Yeah, so I appreciate that PSE provided ample opportunity for our PEG members to understand this presentation. I do feel like reference case A was particularly, presented as weak. It didn't solve. It's way more expensive. So it is hard to jump in and say, well, let's go with reference case A. That's why I feel like I'm not sure when PSE knew that it didn't solve, but it would have been good to have more opportunity for input on that to make sure that the way reference case A, being the currently commercially available technologies, was well represented as a competitor to reference case B and all that is included there. So I guess my answer would be more nuanced compared to others saying that this makes sense. I think that the way that the slides drive the comparison makes it hard to advocate for reference case A.
Thanks for that comment, Katie. Appreciate that.
Hi, this
Yeah,
is Lauren. Can you hear me now?
Oh, go ahead, Lauren.
Okay, thanks. Yeah, my sort of high level observations are I agree. I don't think going with reference case 1 makes much sense. It's just not, I think the likelihood of that case actually being real are very low. And, if nothing else, we want the plan to sort of reflect, something that we do think is actually feasible and reasonable. So I don't think reference case A fits the bill. I also think just, for the sake of the big picture here, these planning exercises are, important for a long-term look. I think what's been a challenge in the CETA era, and we've seen this in every Puget plan basically since CETA was passed, is that, we don't necessarily know what 2045 is going to look like right now. And so we have to make, some assumptions that, do the best to sort of factor in that uncertainty. But at the end of the day, the plan, the important part of the plan is really the near term, the next 5 years, the near term resource decisions that PSE is going to make. I think, in the past, we've sort of solved that 2045 question with some sort of proxy, capacity resource that is sort of TBD in terms of what it looks like. And I guess that still seems reasonable to me, considering that 2045 is, I guess 19 years away at this point. A lot can happen between now and then. In some cases, we are, as a region, I think, counting on having that clean capacity resource. And just because we can't identify what it is at this point, to me, we shouldn't get too hung up on that for the purposes of solving this plan. So yeah, I'll just leave it there for now. Thanks.
Yeah, no, thank you. Great comments, Lauren. Okay, we are gonna take a 5-minute break, and after the break, we're gonna come back and make sure the remaining RPAG members have an opportunity to weigh in on this as well. Thanks for those of you who have done it. We have a 5-minute break starting right now, so please come back at 2:33 sharp. So, Jack, if you could go ahead and put up the timer on the screen so people know when we're starting, that would be great. Have a good break, everybody. All right, everybody, our break is ending in about 42 seconds. So if you hear my voice and you hear your computer, go ahead and come back into the space so we can keep going. I'm gonna wait till the timer officially stops. All right. Ben, you can go ahead and stop sharing that timer, and Jack, if you could share the screen again, that would be great. So what we're gonna do is keep going, doing a little round robin with RPAG members, answering the question again on the table. It's just, given what you just heard from Elizabeth about reference case B being the one where the model worked. What is your gut check on it? Like, do you have any observations about it? Things that PSE should keep in mind as they move forward with it? So we've heard from about 5 folks, and I'm just gonna call people in and not logical order. The next person is Donald. Do you have any thoughts for PSE? Doesn't seem like Donald is here, so we'll circle back to you, Donald. Quinn, you're up next.
Hey, Hillary. Staff, do you mind actually deferring staff towards last, given that there's two of us? And then Sophie
I'm
and I
sorry,
can.
what was that?
Do you mind deferring uh the UTC, so Sophie and I towards last, given that there's two of us, and then Sophie and I can kind of make joint comments?
Oh, sure, I was just gonna call on, yeah, that sounds fine, Quinn. Okay, next is Jamie. Okay, don't think Jamie's here. Megan, are you on? Dennis?
Yes, I'm here.
Okay, got any thoughts for PSE?
I do agree that reference case B is the most effective, and obviously, leaning upon these technologies. I guess it would be nice to know a little bit more about the specifics of the different types of technology, geothermal, um, uh, SMRs, and other things like that, and how they would fit in, and the cost structures, lead times, and some of the issues that I think that are going to be definitely part of the time frame and the complexity, so that as we move into these 2, 5, and 10-year increments, that we really are looking at things that are going to really need PSC's attention. But from a big picture 30,000-foot view, I think it's great, but I think that there needs to be definitely some 30-foot to 1,000-foot to 3,000-foot input into this system, so that we're not assuming too much. We have a lot of detail as we move through. Thank you.
Yeah, thank you, Dennis. Appreciate that comment. Okay, John.
Yeah, thanks for the opportunity to weigh in. I would say that in the work that we do at the council when we're power planning, we've also found that if you don't include emerging technologies in your like long run studies, that you run into a lot more commercial, I guess a lot more of what most folks are considering commercially available, some pretty big builds that run into some kind of optimizer problems. So we've also had issues kind of like this. I think it's probably best practice to have some sort of assumptions about emerging tech in kind of the out years. Um, I think so high level, I think that reference B would definitely be more desirable than reference A from my perspective. Just one comment. One of the key features of including emerging tech resources is that they tend to have kind of some more complementary attributes that fit in well with the commercially available resources. And part of the reason why they drive build cost down and cost down in general is they kind of fit well in a portfolio. I have a little bit of concern about some of the storage capacity contributions in the past, and just a little bit of concern about that dynamic of some of the emerging technologies and how they would fit in terms of capacity contribution going forward. That being said, just as an observation, I think that the including emerging tech is a good idea. So, thanks.
Okay, thank you for those comments, John. Okay, I've called on several names that have not been here, but before we get to Quinn, because I know you want to go at the end, are there other RPAG members who have not had a chance to weigh on those who would like to? Oh, JP, you're back. Great. Go ahead.
Yeah, sorry, I missed probably all of what you're talking about, but I had the fortune of being presented this I think very similar data or very similar content a few days ago. And what I've been thinking is that there is a space here for PSE to frame the outcomes of this reference case and the need for this reference B into a sort of a state-sponsored research agenda where these technologies cannot stay only on paper or in these models. There has to be a push to develop these very low emission or zero emission dispatchable technologies before we reach the 2040 or 2045 date. And so I would welcome sort of the space where the one outcome of this effort is, okay, how do we push our institutional ability or academic ability and formulate a research agenda that produces that technology? And we don't just sit here crossing our fingers that it shows up, but to the earlier points that people had made, that we didn't want to rely on emerging technologies because we didn't know if they would show up. Well, what is the plan to make them show up? And if the ISB is showing that that's the need, then I think that's certainly an outcome that I would like to see here pursued and supported by the state. So starting from the PSE analysis, but supported that by the state. How do we produce these technologies so these ISBs actually achievable in 20 years?
All right, thank you, JP. So kind of a request that with support for reference case B, but maybe an observation or ask that it include more of a detailed plan about how emerging technologies, like how the path towards them might occur.
Or I would say even put it on to be fair, put it on the state and say, okay, folks, I mean, we need a joint partnership here if we want to make these unicorn technologies show up in 20 years and make our plan achievable. It's not going to be magic, and we just shouldn't rely on the market just suddenly and magically doing this. So there should be a concerted effort, a joint, private-public partnership to make these technologies happen, and probably fold in federal support from DOE and others. I know it is not potentially as easy in this administration, but it's 20 years. There's a lot of time to get at that.
Okay, thank you for those comments, JP. Okay, before we pivot to Quinn, any other RPAG members that have not had a chance to go? All right, Quinn, you're up.
Yes.
Hillary, I think Quinn and I are going to make our comments together, if that's okay, since we're both from UTC.
Sure.
So I'll get us started. I guess the first thing is just maybe a suggestion or request, and I think it would help me, clarity-wise, to see maybe a table that specifies the build limits and price assumptions that were incorporated in A and B. I know some information was given on what was allowed or not allowed in each case, but it's still not 100% clear to me, where things were relaxed for B, and to what extent they were with some of the emerging tech. And I know slide 80 was referenced, but on slide 80, I don't see the renewable peaker as in the emerging tech, but I think it was said that it was for B. So just a suggestion that would help me in really parsing these two. And then I think John mentioned this, but I'm not surprised that A didn't solve. From what I've heard, there was a lot taken out as far as removing the renewable peaker and then the emerging tech as well. And so I want to reiterate what Katie said, I think earlier about considering a potential middle ground. And I don't know exactly what that would look like, again, because I don't know what the build limits and price assumptions were for everything in B. But for example, I could be, or one thing that would interest me is seeing A plus some limited builds allowed for RNG for renewable peakers. Does that change the solution significantly? Um, you know, rather than thinking about renewables as a binary of on and off, thinking about, what if we relax them to a certain extent that seems very reasonable, and see what that gives us. So just a suggestion.
Great, thank you so much, Sophie. Quinn, did you want to add?
Uh, yeah, I mean, I think we've kind of covered a lot of ground here in terms of like trying to, and I think something that would probably help clarify things is to the extent that uh we are kind of figuring out whether or not we're just going to go within this meeting just blessing reference B as opposed to kind of interrogating it a bit more and maybe seeing if, like Katie said, we can find a middle ground of that. Because I'm also a little curious to like what point the model, to like what extent through running the model PSE figured out the model couldn't solve. Because I think that would have actually been probably the better time to then interrogate, well, where do we go from here? As which is fine. I think logically landing on let's incorporate more emerging tech back in makes a lot of sense, but
Okay, thank you. Thank you so much, RPAG members, for contributing to that. I know that folks at PSE are absorbing it and it'll get written up post-meeting. There's also, I just wanted to note that a previous RPAG meeting did focus on emerging tech, and I think at some point it's going to get linked in the chat here so people can go back and look at that conversation. And but yeah, like hearing a lot of really good comments, like understanding that reference case B is, I'm hearing a lot of understanding that reference case B, like people understand why that's the path PSE is pursuing, and also some questions about maybe better understanding at what point reference case A stopped resolving, and maybe having a deeper understanding of that would be helpful. So with that, I see a question from Katie. I'm going to call on you, Katie, and then we're going to continue with the presentation so we can keep marching towards the end of this meeting. Go ahead, Katie.
Yeah, it's quick. I just wanted to mention that I clicked on the link Meredith provided, and it seems the presentation and my agenda, and I haven't gone through all of the links, but they're unavailable. So maybe they're a little too old. It's from 2024. So yeah, just wanted to mention that. Thank you.
Okay, we will work behind the scenes on making sure the links are live. Thanks for pointing that out. Okay, with that, we're going to continue with our presentation, and I think at this point, Elizabeth, your piece is done for now, and Sean, I think you're up next. Sean, are you ready to hop on and carry on with this piece of the presentation? Thank you.
Yes, we'll go to the next slide. And hi, everybody who hasn't met me. I'm Sean Foster, Director of Electric Transmission here at PSE. I've been with the company now since September of last year. And so just want to spend a couple of minutes and a couple of slides talking about the transmission landscape and the assumptions used during the development of the ISP and the reference case. And so, conceptually, they should think about it as expanding the work that went into the 23 electric progress report. Gosh, forgive me, I can't speak. With respect to further refining resource zones and regional transmission capacity assumptions. The from baseline, the 2027 ISP capacity expansion model groups resources into unique regions, like you're seeing depicted on the screen, sharing fixed transmission capacity from those zones back to PSE load here in the area. Transmission capacity was modeled as a build limit for each region under the construct that it doesn't make any sense to add additional resources in zones if there's a transmission constraint that exists there. As we're thinking about this, we also have to be cognizant of the paradigm that exists out on the regional transmission system, which largely will involve and pull in Bonneville Power as well, right? They own 75% of the transmission in the region, and they're a key component to any discussion that relates to how do you go out and acquire resources necessary to meet your load service obligations into the future. And so, in doing that, we also have to be cognizant of the fact that, and this is something that Bonneville has said themselves, that today, effectively their transmission system, I think the words they used in it was either late 22 or 23 process, was effectively fully subscribed, and so they've been going through a process to understand what new projects they need to develop in order to meet the needs. It started off being contemplated as what was known as evolving grid. They've subsequently changed the naming convention of the suite of projects, those two tranches of projects, to GURP. I don't remember what the acronym stands for, but that's what they're calling them today. And so as we think about how we analyze this, because there's this sort of prevalent understanding that there are multiple Bonneville cluster studies that make up the GURP projects, and they have an unstudied cluster that exists out there. They've got more transmission service requests than they can study and make solve in their transmission planning models. I mean, the pending cluster study that they're working through right now has almost double the number of megawatts of requested transmission service as the entire region has load. And then you start to layer that on top of all the transmission service that they've granted, historically, and customers have and utilize today. It becomes something that's sort of unwieldy. And then as these projects move forward and they start to identify how the cost allocation for these projects will be handled, there's some anticipation that some of those requesters in their cluster studies will likely withdraw. And so to that end, as we think about how to model it, we included all of the GURP Tranche 1.0 projects in our ISP modeling. And then we limited GURP 2.0 to probably 50%, I think was the number, to sort of reflect the fact that at some point, there's likely to be some withdrawals from Bonneville's queue. And so to that end, when you run the analysis, it still identifies a significant transmission need by 2035, which you'll see on the screen. If you wouldn't mind going to the next slide, if you could. One thing that we should think about is because of the topology of the transmission system and where PSE is in relation to everything else, for the most part, when we're trying to access, whether it be Eastern Washington or resource zones in Idaho and Montana and beyond, or down in Wyoming, for the most part, those will all funnel through Eastern Washington. Some of it will go down and around through Oregon and up, but the majority of the capacity that will be built and that exists today on the existing system in terms of getting transmission to PSE's territory will flow across the Cascades from Eastern Washington into PSE's territory. And so, as we think about that, we have to think about transmission. I kind of think about it as putting all the links of a chain together to be able to get to where you need. So, reaching out from our PSE service territory, we'll need to have additional capacity into Eastern Washington. And then to the extent that we want to reach Idaho and Montana, and or Idaho, Oregon, in Wyoming, we'll have to, put together those different links of the chain to get to those resource zones that we want to see. And so, for us, the key constraints are what's called West of Cascade North, which is a Bonneville, or excuse me, is a WEC path. Bonneville calls it Cross Cascades North. Montana, North Dakota, into Washington. So the Montana to Washington construct, there's multiple flow gates out there. Path 8, another one called West of Hatway, that are major constraints. And then Idaho and into Oregon is a congestion point as well. There's a project out there to try and address some of that, but even that is fully allocated. And there would need to be additional transmission capacity brought to bear, to access those zones above what's already contemplated. So that's what I've got. I don't know, Elizabeth, is anything else?
No, thank you. And as Sean noted, the previous slide, we'll get back to this. That was our transmission limits. Those are the bill limits of the resources from the different zones that we will be going through as well.
So Elizabeth, I think keep going, and we're gonna hold questions until this presentation is over, because we're a little pushed for time right now. So go on, Elizabeth.
All right. And I do have a clarification I need to make, or a correction of previous comments. So there was a question about what's happening in the models and why it's not solving. To clarify, what happened is the original reference didn't solve, and that was because of our build limits and these transmission limits in the model. Reference A did solve, but the manual piece is we had to go in there and remove all of these bill limits to increase the availability of resources in each year and the total availability of resources, and increase these transmission limits to make sure that we can get to the resources and we have enough resources available in the model. So that's just a clarification of what happened. So reference A did solve fine. The manual piece was we had to go in and increase all of the bill limits and these and remove some of these transmission constraints to try and get it to solve into a solution. All right. So with that clarification, we'll go to the next slide. So just noting our reference case is our starting point. I know we've had a lot of discussions. We just need a starting point to get all of our modeling work done. So this is where we're starting with our reference. We will be running through a lot of iterations, and that includes scenarios. So our scenario reference loads are our lowest point of loads we will be working with, and then we will be moving at increasing loads. This will be increasing large loads into the portfolio or a load forecast. This will be increasing EVs. This will also be looking at different electrification or gas to electric type conversion scenarios as well, and we'll be building all of this in. So the point is we have a starting point with the lowest loads. Every other iteration we're looking at these scenarios will be increasing loads beyond this. And this is also where we're trying to get to of what's happening is if in reference A, we're already having to increase build limits, we're already having to go through the transmission limits. This will cause more and more problems as we're going into these increasing load scenarios. So this is where we kind of leaned into B. We put the emerging tech in, B solved with our transmission limits, with all of the build limits intact. We didn't have to do any iterations on that. And so that will also help us get into solutions for scenarios 1 through 4 with increasing loads into the portfolio. So I think the next slide. This will be going through our sensitivities. So as noted, we will be running through a lot of sensitivities. Reference is our starting point. I know we've been working through a lot of different iterations, and on the list is to be working through different iterations of emerging technologies. So we did hear a lot of the feedback of what about some in-betweens, and so we can work through those different emerging technology, what's available in there, some costs, where those emerging technologies are available, and what's happening there. So that's on the list of some of the sensitivities to be testing along with our transmission availability. So as Sean went through, we're working through kind of our set reference of transmission availability. We'll be working through different combinations of a lower transmission available or more transmission available coming out of these different zones with upgrades needed to happen for the increased transmission availability. And then, of course, the lower, what if these upgrades don't happen? What would we be looking at with this portfolio? And this is also really where we're trying to get to, is working through all these scenarios and sensitivities. We need to make sure that the portfolio solves with our base assumptions. And then we'll start iterating off those base assumptions and making changes as we move through these iterations. So these are one-off changes. What we're going to be doing is looking through all of these portfolios, not just the reference, but all of these portfolios, all of these iterations, all of this will eventually go into helping to inform that final resource plan portfolio. So this is really is our starting point, just trying to iterate that. I know there's a lot of discussions on kind of this other points that we can be looking at. So we'll be pulling all of that information back and making and looking through these different sensitivities.
All right, I think that's it, right, Elizabeth?
Yep, that's it
Final
for my
slide.
slides.
Okay, well, thank you to you and Sean for, that was a lot of detail and a lot of information. And thank you to RPAG members for great questions and comments and thoughts. We're at 3 o'clock and we've had a lot of questions and comments already. I see one in the chat from Katie that Katie, I think is going to get answered by Sean in the chat. And when it gets answered, I'll read it out loud to everybody. But in the interest of time, I want to move us on to the final segment. To keep us on time, we are not going to have the gas transmission distribution system presentation by NECE. Instead, we're going to have the first do the gas supply reference case and then the ISP reference case results. And then we'll postpone NECE's presentation until the June meeting. But I do want to just keep in mind, Jack, if you could go back one slide real quickly. I just want to keep in mind that at the end of the meeting, we're going to post a poll for our RPAG members to let us know what topics you really want to deeper dive in the June meeting. And I think we're starting to get a sense of what those might be based on your questions and comments. But one of the things we really want guidance on related to this slide is the sensitivities, like given the challenges that PSE has been up against in running these models, how might they prioritize sensitivities going forward? That's kind of, so we can kind of come back to that in the June meeting. So when you're filling out the poll, I'd love you to think about that. Okay, with that, I'm going to introduce our next speaker, Jennifer Colson, who's the Director of Resource Planning Analytics at PSE. And Jennifer is going to cover the gas supply reference case first, and then the ISP reference case results next. So Jennifer, take it away.
Great, thanks, Hillary. Yeah, so we can go on to the next slide. So similar to the electric side, the gas supply portfolio follows a really similar process. We start with our assumptions, demand forecast, then we move into the portfolio modeling and stochastic analysis and get a plan. And similar to the electric side, we see some iteration regarding that process specifically on the results, synthesizing the results, and then making modifications and rerunning. And eventually this will inform the long-term plan and strategy. And what we're focused on today, I think Elizabeth just mentioned it pretty well, is the reference case. So this is just a starting point. It's not the plan. This is where we will set up our base and then we will iterate from there. And that's what we're focused on for today. So the next slide, we haven't talked about gas supply in a while, so I just wanted to revisit the components of the gas supply portfolio quickly regarding the inputs that we have. So for the gas supply model specifically, we have the gas demand forecast. This is the net zero gas growth forecast. We have incorporated the conservation, removal of the gas appliance conservation in 2027 per HB 1589. We've incorporated natural electrification, the low-income electrification programs, and the targeted electrification pilots are all incorporated into the demand forecast that feeds into this analysis today. We have gas price forecasts. We use our existing resource and contracts. We have carbon adders, so we have the Climate Commitment Act ceiling price. This is part of HB 1589 as well, using that ceiling price. We also have the social cost of greenhouse gas. And then we offer the portfolio various resource alternatives. And really on the gas side, the resource alternatives we have to work with are pipeline contracts, storage, and renewable natural gas. All of this goes into our optimization model, and then based on the demand and peak day requirements and various other constraints within the framework, we get a plan. I'll go to the next slide. This is a chart that we've shown in prior IRP processes, and we wanted to just flash it up one more time with the final numbers that we were able to finalize the final prices. So this is the levelized cost of the natural gas that is used in the ISP. So the box on the left that is the 27 ISP gas commodity prices. It's input into the model. This is using the climate commit max ceiling price. You can see on to the right, those bar graphs are representing prior levelized costs that we used in the 25 analysis and then the 23 IRP. The gas commodity prices have gone up a little bit. We purchased those from a third party, and they say that those are price increases are really due to the domestic power market driving up increase in demand on the gas system. We see the ceiling price in there for the Climate Commitment Act allowances. On top of that, we also have the social cost of greenhouse gas and then the upstream emissions. So all of those things are incorporated into the price and part of the optimization decision for the least cost plan. Okay, we can go to the next slide. This is the total gas supply portfolio costs, laid it out very similarly to the electric side. So you have the 23 IRP on the top, and you can see the 27 ISP reference cases coming in higher. We're largely attributing that to the Climate Commitment Act allowance purchases being at the ceiling price, and so you can see those price increases, and we'll talk about that a bit more. Okay, next slide. One of the resource alternatives we offered the gas supply portfolio was renewable natural gas. This was limited based on existing supply and deliverability to Washington, and this comes in about 4 to 5% of our total fuel mix in the plan and within the planning period. Next slide. This is what we call our resource balance. So the dashed line at the top is the demand forecast that I referenced earlier. It is inclusive of the demand side resources, meaning we've removed conservation from that. So you can see that slope down is from the conservation impacts to the demand forecast. And then everything that builds up to meeting that demand, we have our existing supply side resources. This includes existing contracts and existing storage facilities, and then the additions and RNG, the existing RNG, as well as the SWAR and Plymouth storage resources being added to fill that need. Okay, and go to the next slide. Oh, that was it. Any questions on that before I dive into the full view? Okay, let's go to the next part. I'm sure this will be okay. So this is our first integrated system plan, as we've mentioned probably multiple times today. And as part of that, we're bringing together a different view. This is incorporating not only the electric and gas supply that we kind of deep dived in today about, but it also includes gas and electric T&D and customer programs all together into this planning framework, which is different than our prior IRP processes. And because of HB 5089, we do have to look at the costs of these different scenarios, if you will, through the rate lens. And to do that, then we have to break the cost down a little differently than we've shown in prior IRP or traditional planning cycles. So I'm going to talk through a couple graphics and what those entail and how they attribute to the rate impact slides that we've pulled together. So we can go to the next slide. This is the electric utility reference case. This is incorporating the cost of the electric supply portfolio reference B that we walked through earlier. This incorporates the regional transmission and the local transmission costs that we discussed with Sean about the BPA assumptions. It also includes conservation, demand response, market purchases, and our PSE distribution system costs, as well as a little bit of CCA. This is a cumulative annual view of CapEx and OpEx through the planning horizon. That's not traditionally how we've shown costs in the NIRP, so I just wanted to point that out. And that's important for how we've built up the rate analysis. So this is what's going into that view. This is important to note that this is really purely focused on the scope of the integrated system plan and just those specific areas. This is not a full utility view in from that perspective. Most notably, the electric portfolio costs are the key drivers to the investments over the planning horizon at about 80% of the total spend over time. Okay, so the next slide. These are the electric utility cumulative percent rate increases. This is not PSE's proposed, these are not PSE's rate projections. These are based on the modeling outputs of the reference case that we discussed today and the components that I showed you on the slide previously. So these are increases above the existing rates as they are today based on the modeling assumptions and outputs from the reference case that we just discussed. This is highly variable, obviously, on all of those assumptions regarding the weather, hydro conditions, and actual resources emerging in the timelines that we assumed in the analysis. But what we can see here is that based on all of those assumptions, the projections of rates would increase over time quite significantly by the end of the study period. I can pause here for a moment if there's any. Okay. Oh.
Sorry, I had to get my camera and mic up. Yeah, if you could go back 2 slides. My main question. Oh, did I? Slide 47, sorry. I think my main question here is that it seems like for the most part, portfolio costs are for the driving the rate increases here in line with when you would expect uh when you would expect policy deadlines to kind of hit as you work to comply with CETA. Is that kind of what ended up happening here, where basically the model flowed through the builds, and because the builds all more or less happen to meet CETA, that all the cost increase kind of get put in that like 2030 and 2044 range?
Yeah, so this is based on those components that Elizabeth showed regarding the model is solving for 3 things: the effective peak capacity, the CETA requirements, and the demand forecast. So it's optimizing across all 3 of those areas. So yes, it's solving for CETA, but it's also solving for capacity over the time to meet the demand. Did that help?
It does, and I don't suspect there is, because it sounds like it does kind of a rank order. Is that more or less right? So it's solving for capacity for CETA and then to meet demand in that order.
Is Elizabeth still on here? It's a detailed model question.
All right, so it's solving everything simultaneously. It's not necessarily rank order, but it's all solved simultaneously, and it's trying to optimize to meet everything together at the lowest cost options.
Okay. Think about that a bit more.
Okay. We can go to the next slide. So similarly to the electric side, these are the gas utility reference costs that we've incorporated. So I talked about the gas supply assumptions. So this includes the existing pipeline storage, renewable natural gas costs. Then we have our gas T&D, which we have material in the slides regarding those investments over time. And then most notably, you can see that CCA ceiling price assumption in there and how much that is at the latter half of the plan, about 50% of the total spend over time. Conservation is also on here, I should have mentioned that. This is capital and OpEx over the planning horizon. Again, this is really focused on the builds required to meet the within the ISP scope. So this is not necessarily inclusive of the entire utility. This is really focused on the ISP. We can go to the next slide. So this flows into the cumulative rates for the gas side. Again, these are not PSEs, projected rate increases. These are based on the modeling outputs and the assumptions from the gas reference case that we just discussed. These flow through for a cumulative increase of the existing rates. It is important to note that this is assuming the Climate Commitment Act ceiling price. That is a market, and there are other levels there. So this is on the high side for the ceiling. There's a low Climate Commitment Act price and an expected price that we will be testing in sensitivities on the gas side to provide context there. And I see a note in the chat. So these are nominal. They're inflated at 2.5% interest over time. Any questions on this?
Jennifer, it looks like Dennis has a question.
Yeah, go ahead, Dennis.
Based upon the increases of your gas rates over time and looking at it from an equity perspective, with who your current demographic and current split is, as you look into the future, would these costs go up? I guess have you thought about looking at how that would spread out within the community, and who would be more greatly affected in this transition with the cost increases?
Yeah, that's a good question, Dennis, and something I think we're still trying to figure out. That part of the challenge, especially on the latter half of this view here, is that it's pretty high level regarding where those impacts will occur. So it is a little hard to be terribly specific, but it is a good point and something we can consider regarding the impacts to different demographics and equity.
Thank you.
Yeah, no, thanks for the question. Okay, I did forget I have another slide, so we can go that one. This is looking at the combined emission rates. So the dash line on the screen is based on the Climate Commitment Act's combined utilities proportional share of the statewide emission goal. And so what we're seeing on the screen is the two lines that are reflecting the combined utilities, so the gas and electric utilities emissions. The top line is reflecting the market emission rate that's required in CETA at 0.437, and this is really similar to a peaking unit. And then the bottom line is the orange one is saying there is no emission on market. And the reason for showing both lines is really just to think about the Pacific Northwest is all have clean energy goals, and so we're all working to clean up our energy mix. So over time, the market being as dirty as a peaker may not be maybe an extreme assumption, but assuming the market has no emission is probably likely not correct either. So it's somewhere in the middle. And what we found from this view is that we have made progress in emission reduction in the near term. And so that is a nice find, and that we have some work to do in the latter half of the plan.
Quinn, go ahead.
Sorry, one more for me. I'm very curious to kind of see what this chart would look like broken out into the electric and gas side. Is to see kind of what's more responsible per se for kind of contributing to the line going down versus kind of staying flat.
Yeah, thank you. We can take that back. Okay, can we, let's go to the next slide. Okay, so I just wanted to kind of touch on the key takeaways we talked about at the beginning of the meeting. Now that we've gone through a majority of the content, we have our electric supply optimization model that did not produce a solution based on the assumptions that we used. So we had to do some manual workarounds, as we discussed, about getting a feasible solution out of our electric model. And this is important because this is a reference case. This is our starting point. We have scenarios and sensitivities to continue evaluating, and the load increases on the electric side only go up. So having something that could produce a solution for those future large increases in loads is really helpful and informative to compare portfolios as we go through that scenario analysis. So thanks for walking through that with us today and providing your feedback. We've seen that peak capacity and seeded needs are really significant over the 10-year planning horizon and beyond. We talked a bit about that transmission across the region is significantly constrained and does pose generation risk for getting the generation that we need to meet our reference case demand. The gas supply optimization portfolio was selecting the Climate Commitment Act allowance purchases as well as renewable natural gas to offset emissions. And we also saw that the electric and gas rates are both increasing significantly. This raises concerns regarding affordability. And just wanted to end and just reiterate that this is the beginning. It's the reference case. It's just our starting point. It's not the end. And all the comments and feedbacks we have today is really helpful in consideration as we continue modeling our scenarios and sensitivities and eventually develop a preferred portfolio.
Thank you so much, Jennifer. I appreciate that. And we are going to transition, but we have time for one question, and I'd invite any RPAG member that hasn't had a chance to share yet, if you have any questions for Jennifer. Okay, I'm not seeing any. And just a reminder, as Jennifer said, there's a feedback form that will get reposted in the chat in just a minute. And welcome all feedback from RPAG members on this. And any questions that didn't get answered today, please post them, and PSE will get back to them. But thank you so much, Jennifer, for that great presentation. I know it's a lot for everybody to digest. We're towards the end of our meeting, and I want to make sure that we have time to pivot to public comment period and also walk people through next steps. Before we do that, just super quickly, I just want to remind you one presentation is not getting shared today, and that's Nisi Weatherby's presentation on gas transmission and distribution system planning, that reference case, and that will get covered in the June meeting. So just let you know, thank you, Nisi, for your patience, but we needed to dive into that electric reference case a little deeper than we anticipated. So right now, Jack, I'm going to invite you to please skip to slide 65. And what I'd like to do real quickly is make sure that the raise hand feature is turned on for participants in this meeting. And I'd love to see a show, if you could raise a virtual hand, if you would like to share a public comment. I'm just getting names right now, so we have a sense of numbers. So once Jack, let me know when that feature's turned on.
Give me just a moment and I can get that
Or
up.
I'm sorry, Ben's doing that. I have two fabulous people behind the scenes helping me, Ben and Jack. I'm going to give them a shout out right now. They're doing all the technical magic behind the scenes. So right now, Ben is turning on the raise hand feature for all participants in the meeting. So if you are a member of the public and you are interested in providing public comment, please raise a virtual hand. I'm not going to call on you quite yet. I just am getting a show. So I see James Adcock, great. And let's see. My screen is not showing me. Here we go. I see James. Oh, and Don Marsh. Okay, I see Don first, and then James Adcock. Are there other members of the public who would like to give public comment? I'm gonna give it a couple more seconds, just some people take a minute, so I want to make sure everybody can comment who wants to. All right, I'm not seeing any other hands. Don and James, hang tight. We will call you out in just a moment. First, what I'd like to do is quickly walk through next steps so everybody knows where PSE is going from here post RPAG meeting. So Jack, if you could go ahead and share the next slide. Okay, so super quickly, just so everybody is grounded, this is how the feedback process works for PSE. 1 week prior to these RPAG meetings, the feedback window for the upcoming meeting opens. 3 to 5 days prior to the meeting, the agenda is posted plus the slide deck. Day of meeting, as in right now, we engage RPAG members in feedback on certain elements and then facilitate a public comment opportunity, which we're just about to do. In 1 week from now, the feedback window for this meeting will close. There is a feedback form in the chat, and we invite your feedback on this meeting. So that if that could get reposted in the chats, everybody has it, that would be great. And then a month out, about 4 weeks out, the summary and feedback report will be posted on PSE's website. So next slide, please. Here's the website. You can get tons of information here. I encourage you to visit it. It has all the information about the RPAG meetings, agendas, notes, summary notes when they're ready, and things like that. So I'll give you a second to write down that website if you're looking at it, or take a picture of it. Okay, next slide, please. Okay, just a reminder that our next RPAG meeting is June 4th. Sorry. June 4th is the close date for feedback from this meeting. Our next RPAG meeting is June 23rd. Following that, it's July 28th. And next slide, please. Here is the contact information for getting in touch with PSE. There's an email list. There's a website that I already mentioned. There's a feedback form, and you can also email PSE. Right now, we're going to launch the poll that we've been talking about. This poll is for RPAG members to let PSE know what topics you heard about today that you would really like a deeper dive on at the June meeting, and the agenda will be developed in direct response to your response to that poll. So if Jack, you could launch that poll, or I think it's Ben. Ben, you're launching the poll. Go ahead and launch the poll.
Yeah, the poll is a Microsoft Forms that's in the chat now.
Oh, it's in the chat. The poll is in the chat. Thank you for that. The poll is in the chat. So please, please, RPAG members, be sure to fill out that poll. And next slide, please. Next slide, please, Jack. Okay, now we're finally at public comment opportunity. We have a couple folks who want to make public comments. Just a reminder that you have up to 3 minutes to give your comments. We're going to have a timer on the screen. And we just, again, kind of a reminder, please keep comments constructive for PSE. They welcome all feedback, and your comments and questions will be included in the feedback form. So anybody who isn't speaking, you can fill out the feedback form. If you could go ahead and put the timer up. Jack, I think you're doing the timer. And I'm going to call on Dawn first. Dawn, you can go ahead and come on screen just when there's the timer. Dawn, are you there?
Yeah, can you hear me?
All right, great. All right, your time starts now. Go ahead.
All right, I'm Don Marsh. I chair the Washington Clean Energy Coalition. I'm also a member of the Sierra Club Energy Committee. I would say in general, we are quite concerned, if not alarmed, by some of the information we saw today. We think, there's implications both for our emissions as well as customer prices. But I'm not sure that I understand every slide. I think I had some pretty substantive questions about a few of them. And the fact that I'm not able to ask those questions during the meeting is really a problem, because now I have to share very quickly our observations with partner organizations and with the public. And if I'm getting some of the details wrong, or the analysis I'm not quite understanding, I'm nervous that I'm going to be spreading information that's not accurate, and I really don't want to do that. So I would like to have a contact in PSE that I can review certain slides and questions with quickly here, so that we can meet the June 4th deadline for feedback. That is going to be very difficult for us to try to digest all of the information that's been provided without having all the information we need to make a good comment. So this is not an ideal situation, but if somebody from PSE can be made available to answer questions on a timely basis, we may be able to get through with this. So I encourage you to do that. Otherwise, we're going to have a little bit of a mess, and we really don't want that. You don't want that. So let's do it right. Thank you.
Don, thank you for those comments, and I just want to encourage you to email PSE with any questions that you were unable to get answered today. isp@pse.com. It's also in the chat, and you will get answers to those questions, whatever you were unable to get answered today. So appreciate that comment.
And that will be on a timely basis, I assume.
I'm going to make no comments, not being a PSE employee, but I think they will be on top of it. Okay, I'm going to call up the next.
Like to make a response, so I know where we are. I just, I don't know what PSE's commitment is here.
Yeah, I thank you, Don. I appreciate that. I'm going to go ahead and call up James. James, go ahead. And if we could get the timer back to 3, and then as soon as James is on and talking, you can start the time. James, are you with us? I'm not hearing James. He raised his hand, but I think then that will conclude our public comment period. Last call for James.
He's rejoining as a panelist now.
Sorry, Ben, could you say that again?
James should be rejoining as a panelist now.
Rejoining as a panelist? Okay, we'll give him a...
Okay, can you hear me now?
Yes, James.
All right, I figured it out. We can start now. James Adcock, electrical engineer, MIT, retired. I basically see this presentation as just another in the ongoing 15-year ploy by Puget to say the only solution is natural gas. So we are just going to build more natural gas peakers and combined cycle plants. Puget calls these flex fuel, but they aren't. They're just natural gas plants. Puget, like always, sets up their modeling to plan to fail. Puget has always dragged their feet, planning to fail. By falsely setting up constraints so their models fail, they conclude, oh gosh, our models failed. We have successfully planned to fail. But Google doesn't say, oh gosh, our models fail. They ask instead, what is the solution? And the solution is to add an additional battery technology that already exists, namely iron air. There is nothing that says lithium ion is the only battery technology that Puget can consider. Rather, Puget only considers lithium ion because they are planning to fail. Iron air provides 100 hours of battery backup at 1/10 the cost. While less efficient, iron air can represent a secondary tier of battery technology backup. It works for Google because Google doesn't plan to fail. And then there is also hydro storage, which Puget continues to ignore. Why the continued Puget fixation on natural gas? I suggest that it is well timed that UTC take a very hard look at possible outside of the fence ownership conflicts of interest, biasing the Puget perceived solution to be, gosh, only solution is natural gas. It is always just natural gas, and it will always be just natural gas. Thank you for your consideration.
Thank you for that comment, James. With that, the public comment period is concluded, and really appreciate everybody joining today's meeting. Thank you, my first foray as facilitator here. Learned a lot. I hope you did too. And I'm going to hand it over to Kara Durbin to close us out here. Kara, take it away.
Thanks, Hillary. I'll be brief. I just want to thank everyone for their engagement, appreciate all the good dialogue and questions, and just wanted to reiterate the feedback report is open and available to you. So please send us your questions, your feedback, and your thoughts in particular about how you'd like to spend the time in June, understanding more of the assumptions around the reference case. So thanks again for your time, and we look forward to your feedback. Thanks.
Thanks, Kara. Bye, everybody. Have a great rest of your day.